Okay, we want to spend a little bit of time going through these ionic compounds and how to make the formulas and the names. We'll start with our binary, just two pieces together. This is potassium and iodine. If you look on the periodic table, you see that potassium is here in group 1, so it has a charge of +1, and iodine is over here in group 17, so it has a charge of -1. You take those two things, you put them together, potassium and iodine. You just need one of each of them, since this is a +1, this is a -1, potassium iodine. The name of it becomes potassium instead of saying iodine, you said iodide. You put the IDE at the end for these binary ionic compounds. Our next one is aluminum and bromine. So if I go up here to the periodic table and we look at aluminum is over here in group 13, so it is a +3. And bromine is here in group 17 as well, so it's a -1. So I go back here and aluminum +3, bromine -1. Let's put these together. Again, I have to balance the charge. They have to have a total charge of 0. So therefore, I need 3 of these bromines, all 3 of them at -1, to equal out those 1 aluminums. So my formula will be AlBr3. 3 bromines, 1 aluminum. And my name of it will be aluminum bromide. Again, I cut off the INE and I put on IDE, aluminum bromide. Next, we go into these transition elements. The transition elements, you remember, are these elements that are here from groups 3 through 12, plus also this little corner right here, tin, lead, bismuth. Those guys act like transition elements. And we don't know what their charge is. Remember, these main groups, we know this is a +1, this is a +2, this is a +3, this is a -3, -2, -1. We know those charges, but transition we don't know. So therefore, we have to either be told it or we have to guess it based on the formula. So gold can have a couple of different oxidation numbers. Gold can be a 1+. It can also be a 3+. So let's say I told you that you have gold 1+. We'll use gold 1+ first. So gold has a 1+. Oxygen, we know, is over here in group 16. Here's oxygen. So it's a -2. So if I have a 1+ and a -2, I know I need 2 golds to balance out those 1 oxygens. So therefore, my formula will be AU2O. And I would write this, I'd write the name of it as gold with my Roman numeral 2, excuse me, not a 2, 1, because I make the same mistake some of you did, that this is a 1. The 1 tells me the charge. It does not tell me how many. It tells me the charge. Gold 1 oxide. Now, if we want to go with this gold as a 3+, well, now I have a 3+ and a 2-. So I've got to balance, again, get the same number of positives and negatives. So therefore, I would need 2 of these golds, and I would need 3 of these oxygens in order to balance that out, right? Because that would give me 6+ on this side and 6- on that side. My name of that would be the same, gold, but instead of putting a 1 for the charge, I would put 3 oxide. Again, notice that there are no Roman numerals in the formulas, just in the name. Why do we put them there? Because gold can have multiple oxidation numbers. We move to our next one here. We have copper and we have fluorine. Now, copper can be a 1+. It can also be a 2+. So you need to know which one that is. I would have to either tell you to use copper 2+, or the formula, you'd be able to know that. So let's say we'll use copper 1+ to begin with here. So copper's 1+, and again, it's a transition element, right? Copper's right here. It has multiple oxidation numbers. That's the difference, multiple charges, multiple ions that these guys can form. And fluorine, of course, is over here in group 17. We know that that's a -1. So we'll take our 1+ and our 1-, I'll put them together. They'll simply, one of them will balance, CuF, copper fluoride. So copper, but don't forget, we need our oxidation number, we need our Roman numeral to tell us what charge. And then fluoride. Again, cut off the INE and put "ide" on the end. If we use the 2+ form of copper, then my charge is going to be CuF2, because now I'll need 2 of those -1 fluorines to balance out the 2+ copper. Name stays the same, except I put a 2 for the Roman numeral. Fluoride. So those are our transition elements. You have to have Roman numerals, not in the formula, but in the names. Last but not least, we get down into those polyatomic ions. And remember that those are ions that are made up of lots of different pieces, multiple elements that make up something that has a charge. And that's what's so important. Ion means charge, right? It has a charge with it. So therefore, it's not stable. You have to put it with something else in order to balance. Most of them you can see are anions. They have a negative charge. Only one we really work with, at least currently, is ammonium, that is a cation, a positively charged particle. So let's look at these two. We have aluminum, which again is an element, a plain old element by itself. So aluminum is over here again in group 13. And then we're going to combine that with carbonate. So carbonate, if we look on our chart here, carbonate is right here. CO3 with a 2- charge. So aluminum is a 3+, carbonate is a 2-. Let's put these things together. We know 6 is going to have to be my number to balance. So therefore I need 2 aluminums, right? Because if I have 3+ and 3+, that'll give me 6+. And I need 3 of these carbonates, right? Because 3 2- will equal 6-. And again, these two numbers have to be the same. So aluminum, carbonate. To write my formula for carbonate is CO3. If you look back here again, you can see that, CO3. And how many of them do I need? I need 3 of them. So therefore, I put my parentheses and a 3 goes on the outside. Because again, I need 1, 2, 3 of those things to balance out my 6+ charge. So Al2, that tells me I need 2 aluminums and 3 of the CO3s, 3 of the carbonates. How do I write the name of this thing? Well, easy. Aluminum carbonate. I just simply use those 2 pieces because carbonate, I can't make it carbonide, because that would make this, instead of being CO3, it would just be C. We can't do that. So we just leave the name. For a polyatomic ion, you leave that anion name alone. I don't change it. I leave it alone. Last but not least, with ammonium. Ammonium and sulfate. Here are 2 polyatomic ions coming together. So ammonium, like we said, is up here, our NH4 1+. And we're going to combine that with sulfate. And sulfate is here, SO4 2-. So this is a 1+, and this is a 2-. So I know that I'm going to need 2 of these 1+s to balance out 1 of these 2-. So therefore my formula, NH4 is ammonium, and I need 2 of those to balance out 1 sulfate, which is SO4. So there's the formula, NH4, 2 in the parentheses, and SO4. Notice, again, that I am not including any charges. There are no charges on these ions. because they don't have a charge anymore, right? You've balanced them. You've put a positive with a negative. So there's no charge present there. The name of this, very simple. Just simply combine the two things together. Ammonium. Wow, I'm sorry, I can't spell. Ammonium sulfate. If you made it through this far, I would encourage you, practice. Go to chapter 7, especially chapter 7.3, and there are practice problems that are there. The answers are on the back of your book. Practice those, try them. Go through your lab pieces, so that way you can prepare and know how to do these things for the test on Monday.